Okay, so now we're going to be looking at describing change, right? So now we're going to be looking at how we describe change using integration, okay? So in real life, numbers aren't going to stay still for our calculations. So if I said something like, I drove at 40 miles an hour for 2 hours, is this really what happened, or is that just a convenient way of saying it? You know, there'll be a time when you just got in your car, started driving, it would have been slower till you got to your maximum speed, and it's not really an accurate way of thinking about things. But we have this other formula, which we know is kind of true, that my distance is equal to my speed times my time. But this only works if you're always traveling at the same speed, okay? Otherwise, that kind of falls flat. So it doesn't really give us any insight into what's happened. It just kind of tells us if we've got one number and we're doing that for all time, okay? So it doesn't really help. But how can you figure out how far you've traveled when something like you're in your car and the speed's going to be constantly changing? So how are you going to figure that out? Well, what you're going to have to do is think about, I'll tell you what, I'll think about a real life example, right? Which will make things seem more grounded. So let's imagine that for every second I'm traveling, I go twice that speed in miles per hour. So 1 second I'm traveling 2 miles per hour, 2 seconds 4 miles per hour, etc. And this is a graph of my speed and time. Okay, so you can see over time my speed's getting greater and greater. So from this, can we figure out what our distance has been, how far I've traveled? Here we go. So let's see if we can make this into some kind of form that makes it a lot simpler, maybe more intuitive to understand. So now that I have an equation for my speed, I've said that my speed is equal to 2 times the time. So that's what I meant when at 1 mile per hour, 1 second, 2 miles per hour, etc. So I can stick this in here, right? And when you've got something like this where speed is dependent on time, you'd say that speed is a function of time, okay? So they're related. Speed is a function of this, okay? So now that I've got that, I can plug this in. So I can say distance is equal to speed, which is a function of time, times time, okay? Then I would say speed, which is a function of time at any instant, is equal to 2t. This is basically what I said here. Okay, so now plugging this in, I'm left with distance equals 2 of t times t. Right. Now, is this helping us at all? Like, do we have to pick, what t do we pick here? You know, if we just pick one time, won't that just be a constant for all time? Like, I feel like we're in the same position. So what are we going to have to do to make this make more sense? Well, basically, this is where the difference between regular multiplication and integration comes into play, okay? This is the big perspective shift, and hopefully this makes sense to you, okay? So with regular multiplication, you take an amount of distance moved in 1 second and you just assume it's the same for every time. So that 2 miles an hour, 40 miles an hour for 2 hours, you just multiply that up and say, okay, I've driven 80 miles, okay? But in real life, we know that for every different second, you're going to be moving at different speeds. So what we can do is you want to split it up bit by bit and think of every kind of moment as its own little chunk, okay? And every little chunk here has its own individual speed, and then it has its own distance that's traveled, okay? So instead of having one big chunk here, where it's your constant speed times that time, and that gives you your distance, what you'd want to do is figure out the distance for each of these individual chunks, right? And then add them all together. So that you assume that the speed is constant for that tiny fraction in time, right? So let's have a look at this. Let's see if this makes sense. So let's try and add up all the distances here. So here it would be 2 times the width of 1, so that's 2. Then this is 2 times 1 times a height of 4. Then here you have 1 times a height of 6. And here you have 1 times a height of 8. And here you have 1 times a height of 10. Okay, and what is that going to equal to? 2 plus 4 is 6, 12 plus 20. So this is 30 meters we're saying we've traveled.